guys, this is going to be very quick. All right, so if I put that off. Okay, so the first one on packet 3 is there's a lot of answer choices that you can put together to be correct. There's not just one answer choice. So it says choose an ordered pair, value, a phrase, and a word to complete the statement. You are just trying to make a complete sentence with everything you fill in. So there are more than one series of correct answers. So I like to pick greater than 1 because I automatically think 2. Okay, they don't give you a number, but we're going to use that to help us. Okay, and then you have 3 different points. You have 2, 4, you have 3, 3, and you have 4, 4. So you have 2 points that are on the line and 1 point that is off of the line. Okay, so I'm going to start with 3, 3. Okay, so if I start here and I dilate it by a scale factor of 2, that means M has to get twice the distance away. If it's down 1, right 1, you need to do that twice. So that's where M prime would be. All right, and then if you did the same thing with N, it's up 1, left 1, and you need to do that twice. This is using the slope method. Up 1, left 1 again, that means it's twice as far away. And so this is where your N prime would be, and then you answer your choices. So the length of MN is longer or shorter. Well, it's going to be shorter because your scale factor is greater than 1. Then M prime, N prime, and N prime, N prime. This is really the important question. You really need to do it on the graph to figure out if it's parallel to or on top of. And this one happens to be on top of. Okay, so then we're going to try, let's stick with greater than 1 just because it's easy. And now let's do 4, 4. Okay, so this is the point that we're dilating about. All right, so if we get twice the distance away from this line, if M is 2 below, it's going to go to further away. So that's where M prime would be. Then we're going to do the same thing. If N is 2 to the left, it's going to be 2 more to the left. It's going to be twice the distance away. So that's where N prime is going to be. So then if you connect them, as you can see, since it was not on the line, it is going to be parallel to, because they have the same slope. If you look at your slope here, down 2 over 2, this is down 4 over 4. 2 over 2 is 1. 4 over 4 is also equal to 1. And however, because we have greater than 1, MN should stay shorter. The original one should stay shorter. So like you can see, there's different options here. All right, so let's look at, I believe this is number 2. Yeah, number 2. This one kind of gets off the graph a little bit, so you can do it on here, but you may need, like if you wanted it to be neater, you could do it, you could dilate it on a different sheet of paper. Okay, so they give you MNO, and they say that they want to dilate it about this point, which happens to be M. So when you dilate it, and you're dilating by a scale factor of 3/2, which is greater than 1. If you divide that, you get 1.5. So this shape is going to be 1.5 times as big. So I'm going to use slope. You can use whatever you want. So to get from M to O, you go down 1, 2, 3, 4, 5, 6, 7, 8. So you go down 8, and you go right 1, 2, 3, 4, 5.
Ellie Gillespie, please come to the front office. Ellie Gillespie, please come to the front office.
And you can think about this 2 different ways. If you go down 8 over 6 once, that's 1, and then you need 1/2 of that. So you would go down 4 and then over 3. That's an option. Okay, you could also multiply this by 1.5. And so you would get down 12 and over 9. And then you would start back again. 8, 9, 10, 11, 12. 6, 7, 8, 9. So it's, you see the 1.5 there, or down 12 over 9 is 1.5, whatever way you want to look at that. So your O prime is going to be here. Then M to N is the same way, down 2, 4, 6, 8, 10. So down 10 and left 1, 2, 3, 4. So down 1.5 would be 10 and 5, which means it'd be down 15, and over 6. 4.5 of that would be 6 together. So that is where you're going to end up getting off the graph. Or you could go an additional 5, an additional 2. 1, 2, 3, 4, 5, 1, 2. So then N should be somewhere right there. All right. One thing to remember is when you are dilating, when you get, it's in the same line. So O should be 1.5 times down and right from N. O and O prime should be in line with each other. Same thing with M and N and N prime. They should all be in line with each other. They spread out from the center of origin the same. So then this is your, and M is not going to move because it is, because that's your center of dilation. It's just like center of rotation. It doesn't move. All right, so then you just answer all your questions. So M prime, N prime is shorter than, well, it's not shorter, it's longer. So that's out. ON is shorter than, yes, the original shape is shorter because the scale factor is 1.5. You're getting bigger. ON, oh my bad, OM is longer. It's not, it's shorter. The big one is this one. Oh no, just kidding. ON, this line right here is parallel to O prime, N prime, and you can count that. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So up 2 over 10. And then the same thing here. Oh, this is where this is tricky. I think this was 2. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You got to see, are those equivalent? They should be. Times 1.5 equals 3 times 1.5 equals 15. So they are equivalent. So your lines are parallel. The one that's tricky is this one. OM is parallel to O prime, N prime. So they're the same line. And so, yes, they have the same slope, which makes lines parallel, but you only have one line now. And to have parallel lines, you need 2 lines. So this one is actually out because they're the same line. One line is not parallel to itself. And then M prime, N prime coincides with, coincides means on top of. So this one is true. So it's the second, fourth, and sixth option. Okay. For this one, I'm going to explain to you what to do, but you should really graph this. Because my graph isn't going to be great because I just don't have one right here for you right this second. So if you read my hint, you dilate a line just like you dilate a figure. You dilate the points. So remember, this is your y-intercept. So you start at 1, and then the slope is 2 over 1. So you go up to right 1, down to left 1. So we're just going to generally get your equation there. You're going to dilate it by a scale factor of 3 centered at 2, 5. So let's see, 2, 1, 2, 3, 4, 5, which should be a point. So this is 2, 5. That should be a point on your line over 1. Yeah. And it's telling you to dilate it by a scale factor of 3. So that means you're taking all of these points and you're making them the distance 3. So if you're dilating this point right here, if you go down to left 1 once, down to left 1 twice, down to left 1 3 times. This point is now going to be here. So they're going to triple their distance between that point. So it says the equation of the new line is 6x plus 3. Well, if this is one of those points, and you can keep dilating, but kind of keep doing that. Then when you get to these two, you need to put these equations in slope-intercept form. So you need to multiply. So you get y minus 5 equals 6x minus 12. And then you need to add the 5 to both sides. So this is actually y equals 6x, what's that, minus 7? Okay, you need to do that so you can figure out what the slope-intercept form is, and then you can match it to the line that you dilated in. And then the very last one, you're going to do that for the next one, and then the dilation would result in the same line. And remember, lines go on forever, okay? So the same line, you're not really talking about are the points exactly the same. As long as they fall on the same line, they would be. So you can do this problem now that I've explained it. Okay, you're going to do the exact same thing for number 4, but it's a line segment this time. So a line segment does not go on forever. PQ is a specific piece. It's like one side of a triangle. And it says select the dilations who would result in P prime Q prime lying on top of PQ. You really need to graph this and go through all of these dilations. One thing that I would say, like 7/2, I would divide that. And so it's 7 divided by 2, 3.5. So it's 3.5 times as big. I think that that would be helpful for you. This is the same thing. You're going to graph those 2 points. You're going to center them at the distance. You're going to dilate them. And some of them obviously have harder dilations, like 3/7 is really hard to dilate by. However, look and see what, like, think about what's going to make it parallel and shorter than. So the dilation has to be shorter than the original one. So the only way that you make things smaller is by a scale factor less than 1. So that should really eliminate some of these answer choices. Okay, this one right here, it goes with this. So you're going to do 2 transformations to take this pentagon onto this other pentagon, and they give you your options there. It's a little tougher because your scale factors aren't like 2, but this is a ratio. And they're talking about the distance of the bigger one or the smaller one over the other one. So that will give you whether it's greater than 1 or less than 1. Okay. So for instance, let's see, YS over HW. So if they give you the scale factor is YS over HW, YS is small and HW is big. So you have a small number over a big number. That's going to be a scale factor that's less than 1. Okay, so just kind of think about that when you're picking your answer choices. It's really hard to go through these when they're so big on the board. So go through some of these. I'm going to try to get to some of the other ones. We didn't do this in class, so if you're struggling with this, it's normal. You can try it, but you can skip this problem. What problem is this? This is number 10. You can skip this for right now. We may have time to go over it together. Okay, let's get to some of the triangle ones because I think these are going to be easier for y'all to do today anyways. So let's get to number 15. So this is still a dilation problem. You can read it, The length of the lighthouse's shadow is 70 feet. So you need to label that. The height of the stick is 3 feet. And its shadow is 1.2 feet. Find the height of the lighthouse. So we're solving for this. So this is all about scale factors. How did you get from 70 to 1.2? So I like to set these up height over shadow. Shadow is equal to height over shadow. So it's a proportion. These scale up or down proportionally. So x over 70 is equal to 3 over 1.2. So you can kind of work these either way. What do you multiply 1.2 by to get 70? You can scale up that way. You can scale down. I personally think solving the proportion cross multiplying is the easiest method. 3 times 70 is 210. Hopefully, as long as my brain's working. Yep. And then you get 1.2x divided by 1.2. And you get the height is 175 feet. And then if you divide these, 175 divided by 70, you get 2.5. 3 divided by 1.2, you also get 2.5, which means your ratio is equivalent to each other. Let's see. All right, let's go to number 6. Wait, let's do 16. Let's go in order. All right, so it says in the diagram shown of the BA is 8 and C is 35. Which single function can be used to determine the length of BC? So you're trying to figure out how you can find your hypotenuse. So if you're solving for your hypotenuse, can you use tan? Well, tan is opposite over adjacent. So this would help you find AC. So you don't need that. Now it says 8 times the cosine of 35. Well, you're going to need to set up this problem first. All right, so we're talking about cosine of 35. So cosine of 35 and cosine is adjacent over hypotenuse. So that would be AC over the hypotenuse BC. All right, and so you don't use 8 there. And so then you would multiply by BC on both sides. And we don't know what BC is, so that one doesn't work. So we know that you can't use 1 or 2. The next one, once again, we're talking about sine of 55. A few people are like, well, we can't use 55 because it's not part of the triangle. It actually is. 180 minus this 90 minus 35, this angle is 55. All right, so if you're talking about sine of 55, sine of 55, the opposite is AC over the hypotenuse is BC. And once again, that doesn't use 8. So you'd multiply by BC again on both sides. And that is what you would end up getting, which is not what's given. So it's not A, it's not B, it's not C. It should be D. Let's see. So remember, this is 55. So it's talking about 8 divided by cosine of 55. So you're using cosine. So cosine of 55 is adjacent over hypotenuse. So we do get our 8 in there. 8 over, we're going to call BCX. So then you multiply by x on both sides. That cancels. And then the only way for you to get x by itself is to divide by cos of 55 on both sides. And that is exactly what you get. So your answer is D. Remember, use your notes. Okay, it's been a minute since you've done this. Find the missing values. I think all of you should be able to do this. You can you can solve for this value first. And get an answer there because you know it's got to be a right triangle, so you can use Pythagorean theorem and solve for it. You could also call it x if you wanted to and set up those ratios that way. Okay, this one's super important. This is the last one that we're going to do because I have to leave, and hopefully you can do that last one by yourself. Okay, so this one's really confusing. All right, so which of the following statements represent the relationship between sine and cosine? Okay, so this isn't in your notes. I probably should have done this, but do you remember talking about sine of A is equal to cosine of B? And that's all because, say you have this triangle, let's call it like, I don't know, 3, 4, 5, and A, B, C. Okay, so if you have sine of A, well, it's going to be opposite over hypotenuse, so 4 over 5. If you have cosine of B, that means you're talking about the side that is beside B, which is always across from A. So you're going to get the same ratio every time, because sine and cosine also are over the hypotenuse. So your denominator is always the same. So sine of A is equal to cosine of B. Sine of one of the angles is equal to cosine of the other angle. And that's what this question is asking. Now, the only thing is they write it really, really weird, but I'm going to show you where they get this from. All right, so this 90 minus A. Well, they're really talking about B, and I'm going to show you why. So if you start with a triangle, you start with 180. If you go ahead and subtract this right angle, you're automatically left with 90 in all triangles. And when they subtract A, that means they're taking out this angle, they're taking out that angle, and you're left with B. And so that is what that means. So this is telling you sine of A is the same as cosine of B. So that's true. 90 plus B, that means you're adding another angle. Okay, so you can't add another angle, so this goes out. 90 minus 2A's, again, 2A's, you're going to have two angles. That doesn't work. 90 plus A, again, you're adding an angle. 90 minus B, so cosine of B, well, if you take out, you already took out the 90, that's how you got the 90. And then if you take out B, you're left with A, so that is talking about A. Cosine of B is equal to sine of A, same thing. So it's your first and last. All right, good luck. See you guys on Monday. Hi, Cohen. Shout out.